Okay, thank you, Brian, for that introduction. Yeah, I'm Jason, and today I'm going to be talking about UIClip, which is a project where we built a data-driven model for assessing UI designs. And this is work I did together with my collaborators, Yi Hao, Amanda Lee, Amanda Swearingen, Jeff Bigham, and Jeff Nichols. So that's 2 Amandas and 2 Jeffs. So the first question is, how do machine learning models or even people assess user interface designs? And this is a deceptively hard problem because it's often quite easy to recognize a good design, but if you're asked to write down exactly why or come up with a rubric, then it becomes a lot harder. And there are guidelines or heuristics out there, but those are usually pretty high level and not really concrete enough to really quantify the quality of a design. So it would be great if machine learning models could automatically assess or help us assess designs. So how well do existing models do at this task? And to find out, we came up with a small experiment to try and measure the design proficiency of ML models. So first, we manually wrote code to implement a simple app, in this case, a shopping app. And since we wrote the code for that app, we can tweak it to intentionally create several suboptimal versions of it. So here's one with a poor contrasting background that makes text hard to read. And I can also introduce other defects, so things like increasing the text size too much so that it causes line overflows. Or I can even mix these two together and generate more combinations. Then we can check and see if LLMs or various other models can identify which screenshot is better. And in this case, it should be the original one. For this illustration, I'm prompting GPT-4v based on a well-known set of guidelines and asking it to choose in zero-shot capacity which out of these 2 screenshots are better and explain why. And what we see is that it does a pretty bad job. So here it states that the screenshot on the left is better designed and provides a list of reasons that aren't really correct. So it's saying the UI elements are more consistent and better aligned. And so like the short answer to this question is basically no. Machine learning models don't seem to be able to assess UI designs well out of the box. And among a couple of models we tried at this task, pretty much all of them got only around 50% accuracy, which is basically a coin toss because there's only 2 possibilities here. And it's actually a little bit worse than that because we found GPT-4 really likes choosing whatever screenshot is on the left. So even if you randomize the ordering, it tends to say the one on the left is better. So the reasoning it gave was also incorrect. It contained a lot of hallucinated details, and it's often unable to understand trade-offs in design. So it might often say, hey, like the one on the left has bigger text, and bigger text equals better readability, so that's what makes it better. But doing that also incurs different side effects, and you might actually want text to be smaller in some cases to create contrast. So in our project, we wanted to create a data set that captures this idea of design assessment. And we focused on comparisons because, remember, there isn't really a great rubric to rate UIs and give them a single absolute score. But if I gave you 2 UIs, it might be easier for you to tell me which one you like more. And mathematically, there are actually methods to go from one to the other. So we came up with 2 different ways to get a large enough data set of preference pairs to train ML models. And one way to do this is to reuse that procedure from the experiment I described earlier to synthetically generate a data set. So we built a web crawler that visits web pages, and it'll first take a screenshot of the original appearance of the web page, and then the crawler will run some JavaScript code called jitter functions that randomly injects design defects based on a set of design guidelines, and then it'll take our screenshot afterwards. And so now we have that quote-unquote good original UI with a bunch of suboptimal variations, and we use this to generate and rank 2.3 million UI pairs. But this approach kind of only focuses on obvious design defects. So we also collected feedback on a smaller set of 1,200 real-world app UIs ranked by human designers. And so these are definitely more reflective of subjective preferences. So in addition to this idea of getting preference pairs, we can also generate textual descriptions of screenshots that are enriched with design information. So we can start with this UI and a basic caption, like homepage of a tech foundation. And for the original or good UI, we can like prepend a prefix that says, well-designed homepage of a tech foundation. And for the jittered one or non-preferred one, we can change that to poorly designed homepage of a tech foundation. And again, we also know what's wrong with the UI because we can look at which jitter functions were executed, or in the case of the human annotated pairs, we ask them to provide some reasoning. And we can add all this information into the enriched description in the form of additional tags. So if you've ever done prompting for Stable Diffusion or Midjourney, it's kind of like that, but in reverse. And the format of this data turns out to be really great for training a multimodal model called CLIP, which helps us transform these pairs into numerical scores. So CLIP is this dual encoder transformer that encodes text and image inputs and computes a number, a score for each pair that represents how semantically related they are. So in this example, the text input is photo of an apple resting on its side, and the corresponding image gets a high score of 0.94 because they are related. But if the image is unrelated like a cat, you would get a low score instead. But unfortunately, CLIP by default does not work well for UI-related data. And we also wanted to calibrate it so that the score of a screenshot that's well-designed should be higher than one with some design issues or is not preferred. So we used our data to fine-tune CLIP and create UIClip. And this model, by doing that, this model actually learns to better understand UI data and adhere to those properties that we want about the design scoring. So with UIClip, if you wanted to assign a score to a UI that represents its design quality, you can just feed in that screenshot and a description containing the tag well-designed. And the numerical output would correspond to design quality, because remember, from our data set, screenshots of higher quality are associated with this well-designed tag. So it kind of computes the probability that your screenshot is well-designed. You could also have one text input but multiple image inputs, so we found this was really helpful for improving generation capabilities of LLMs. So what happens right now is you could provide some prompt to an LLM, and it'll just respond with the first UI that it generates. But instead of that, we actually want the best UI. So we can generate multiple outputs and then render them and then score them with UIClip, and then instead we can return the output with the highest quality. You can also feed in a single UI image and then multiple text descriptions. So this turns out to be really useful for generating design suggestions because you can create multiple text descriptions where each contains a tag of a potential problem, like bad readability or bad contrast. And here the numerical score represents, like, given the image, what's the probability that that screenshot contains this design flaw. And because in our data set, we associated these tags with the corresponding jittered images and non-preferred images. So please check out our poster, or we had a demo where we showed example applications built on these techniques. So how well does this model work? To find out, we ran several evaluations. So here I'll just focus on one of them where we used UIClip and some baseline models to, again, predict a preferred item in UI pairs, and a held out sample of the synthetic data and also human-rated data. And we can see the results summarized in this figure where, from the previous experiment, we already know that the problem of assessing UI designs is challenging for today's largest proprietary LLM. So it only gets around 50% accuracy for zero shot. And the same also goes for open source alternatives, which ironically sometimes performed better because we found that GPT-4 sometimes actually refused to respond to our prompt. So it'll say like, oh, sorry, I can't help you with that task. And we did some ablation analysis that shows if you just use existing online data sets of UI screenshots paired with captions, this alone isn't actually enough to learn design assessment because that data doesn't contain the necessary information to differentiate quality. So that also doesn't perform as well. So finally, variations of our UIClip model shown in bold here are significantly more accurate than baselines in both data sets. So more details and some other evaluations can be found in our paper. So to conclude, in our current work, we built UIClip, which is a data-driven model for design assessment. And we contrast this to some other design critique work that's about to also be presented in this session, in that we'd like to quantify design quality rather than providing potentially useful feedback. Because having this score that can be used to compare and filter samples enables a lot of new applications, and this is particularly true in the machine learning space. In our work, we were able to train a model on preference pairs that we generated, and we found that it could outperform all existing approaches. So we see a couple of avenues for future work. So first, our goal of quantifying design as a single number also limits our model in different ways. So we'd like to look a little bit more at the trade-offs there. Another interesting thing we'd like to investigate is the context behind some of these design preferences, especially those provided by our human raters. So for example, we found that iOS users might rate certain design patterns more favorably because of their own familiarity using them in iOS apps. And finally, I think UIClip is an example of how we can try and quantify and model human factors that we talk about all the time in HCI, like visual design, usability, and so on. And we can, by doing this, we can make it useful for a lot of new applications. And with that, I'd like to answer any questions and encourage you all to visit our project page where we're releasing all of our models and data. Thanks. Right.
And in your pipeline, you utilize models and data sets across different time spans. Like you have some mobile data from 10 years ago or something, and you have some new release from data nowadays. How do you think this kind of mixture has impacted your pipeline?
Yeah, that's really interesting. I think, yeah, so we did evaluate on some apps from like Rico, for example, and they look a little bit different. They were from a couple of years ago. And I think it's because at that time, kind of the best, like the guidelines for creating UIs were different, right? So it's really a question of like, well, how do you evaluate UIs using a different set of guidelines, right? Like if we want to evaluate like this screen with conformance to material design V2 or like the Apple HIG, right? So I think that's a really interesting future work. Where it fits into here is I think maybe that the kind of design guidelines, the things you care about, maybe that can also be included into the textual prompt. So instead of like UI screenshot, well-designed, homepage or whatever, it could be UI screenshot, well-designed according to material guidelines or material design or like a list of guidelines, and then that score would actually represent its conformance there. So I think there's a lot of interesting work to do in that space. Yeah.
Shumin Chai, Google. So if I get it, this work in particular focused more UI in the sense of static layout aspects of it. Would the more dynamic or more interactive aspects of problems be better suited for large language models or Gen AI because the deeper knowledge it somehow learned in pre-training?
Yeah, I think so. I think it's like there's kind of two parts of this. Like, there's one part is like the goal of quantifying the quality of an app into a number, and there's also like our model architecture. So our particular model architecture here is like clip. So that's like just a single screenshot. So I think that would probably not be that, like that's best suited for a single screenshot. But this idea of like, maybe an LLM or a VLM could crawl something, right? So that would be better for a VLM. But this idea of still mapping that, like trying to quantify that value, I think is, like along the same lines of work. And I think if we wanted to do that, like a VLM or that kind of model would be useful.
Or the information architectural aspect or navigational aspects of a UI, which even for usability studies is hard because you cannot run that deep, that large scale, generally quite expensive.
Mm-hmm.
But that might be an aspect that large language models could do better in the long run.
Yeah, I think for sure there's a lot of potential there, yeah.